Let me talk in detail about std vector. Std vector is a container which belongs to standard template library containers of C++. It is a templated class which manages an array in dynamic memory space, and it, which means std vector, offers several functionalities to manage this array. For example, for accessing elements, for accessing first and last elements, for inserting elements, for removing elements, etc. You would want to use std vector in the situation where you want very fast random access to its elements, and you want to minimally insert or remove the elements from it. That means you don't want to very frequently keep inserting and removing element into it. That may degrade the performance of the use of the std vector, but the main advantage of using std vector is it gives very fast random access to its content. Let me use this space to explain it through coding directly. To use std vector, you want to include the library called vector. It will give you access to a class called vector, which is in the namespace called std. And since this is a template class, you need to specify the type you want to instantiate it for. In this case, I am going to be using fundamental type integer to make it simple, and I want to give the name of the vector object to be ivec. So this is the way you can create a vector, and it will create a vector by invoking default constructor. So essentially it will create an empty vector, which means you have a name, but it doesn't have any space to store the data in it, and it doesn't have any content, right? So you can see, you can access the capacity of this vector by invoking the member method of this class called capacity. This method will return the capacity of this vector. You want to call this function through the object. So I want to actually see what this capacity, this function actually returns. So let me push it into, insert it into the standard output. So this is a capacity, and also there is another feature of this vector which is called size. So I want to see both size and capacity. So this should display both size and capacity of this vector that was created by invoking the default constructor. Let me try to compile this code and see what the output looks like. So compilation and linking and execution. So you can see the size and capacity both 0. That means it is an empty vector, so which is actually expected. Size and capacity 0 is expected through an empty vector. It's also possible that you can create a vector by invoking not default but some other constructor, some custom constructor. Let me give a different name, and you can pass the data, let's say 20 into it. So this statement will create a vector of size and capacity 20. It creates a vector by invoking custom constructor. So it creates a vector of capacity 20 and size 20. We can display that the same for this vector I bake 1 and I bake 2. So let us see whether it shows what we actually want to see or not. In the second case, both size and capacity is 20, right? That means this vector has 20 memory spaces to store the integer type elements, and that is the capacity, and all the elements are actually occupied, and the value that are occupied in this case is the 0. When you create the vector like this, it actually creates a vector with 20 elements, but it sets all the elements to value 0. So you can access the element by through the indexing operator. So if you want to display this the elements to the standard output, you can iterate this. You can put this cout statement in a loop, plus, and the type of the data that size actually returns is not going to be integer type, so probably it will complain with a warning. So just to avoid that warning, I want to use the type of the data that actually this size will actually return. Right. Let me see the output of this statement. I expect this line will display all zeros, so but want to make sure that actually what that is exactly what we see. So you can see all the elements are set to 0. Back to the code, and there is another way of creating the vector. In addition to this capacity, you can also pass data that you want to set into the elements. For example, instead of setting all the data to 0 at the time of creation, I want to set all the elements to 200 value. So again, this statement creates a vector object by invoking custom constructor, but it is a custom constructor which receives 2 arguments. Right. Let me display the size and capacity for this vector and the data. And also you can it's also fashionable to use a range based for loop in this case when you are actually displaying data from the vector. So using range based for loop, so this will actually display the content of the second vector. Compilation and linking and execution. You can see all the elements are set to 200 in this case. Right. So these are different ways of creating a vector, and it's also possible that you can add elements. Once you create a vector, you can keep adding element to it. For example, in ibake 1, if I want to add more elements, then there is a function called push back. I want to push 100. Let me start by pushing 50, and let me display size and capacity. Right, Now let me show you the output before I push further data into it. So now once one data was pushed, the size became 1 and capacity 1. Now let me push another data. I want to push 100 and see the output. So you can see size capacity 2, and I want to push 150. See the output. Size and capacities. Now you can see a little bit interesting thing here. Size is 3, the capacity is 4. Okay, let me continue with this a little bit more, then I will come back and explain why it is happening here. The size is increased from 2 to 3, but capacity increased from 2 to 4. Okay, so let me do a little bit more pushing. 200, then 250, 300, 350, 400. So to show you in the code, I actually pushed 150 and then 200, 250, 300, 350 and 400, and after each pushing operation I actually have a statement to display the size and capacity. Right, let me compile this code and show you the output. So now you can see in the first case it was a size capacity 1, size 2 capacity 2, size 3 capacity 4, then size 4 capacity same, no change, size 5, and then capacity jumped from 4 to 8, and size 6 capacity 8, 7 capacity 8, 8 capacity 8. It would be interesting to see what happens in the next step, because now the size has reached 8, then where does this capacity jump to if I add one more element to it. So let me do it. 450, now it jumped to 8 to 16. So the vector is designed to keep increasing the capacity, but not directly with respect to the size, but it will increase the capacity by certain amount so that it doesn't need to keep increasing it for few more additional insertion of the element or pushing of the elements into the vector, because each time it increases capacity internally, there is a lot of the data is stored in the dynamic memory space, and it has to allocate a new memory space. It has to copy all the data from the previous object to the new object. It will need to release or delete the memory space. So allocation and copying data requires computational resource that is not actually desired. So you want to minimize that kind of copying. So that's the reason why it actually when it jumped from 2 to for size from 2 to 3, then it allocated to the capacity, it allocated the space for 4 elements, so that next addition did not require it to allocate a new memory space and transfer the data into it. Now after that, it allocated memory for to make the capacity 8 so that it didn't have to do that kind of expensive copying for these additions 5, 6, 7, 8, right? Then after that it increased to 16. So now if you increase add from additional from additional element to increase up to the size 16, it will not have to transfer the data, right? So for the sake of that, to make to to avoid that sort of frequent copying, it actually does allocate the capacity by a little bit extra amount. Yeah, this is how it is actually internally implemented. That's the reason why if you want to keep increasing the capacity and decreasing the capacity, then that may actually cost you extra overhead, making the use of this container less efficient. Now going back to the code again, now I will demonstrate some additional features to it. There are some additional functions that you can use it used to see and access the information of the vector. If I want to see whether this vector is empty or not, I can call the method called empty. If I want to display this information in the standard output as a Boolean output, so it will display either true or false depending on whether the vector is empty or not. In this case it's not empty, so it should display false. You can clear the vector. It will actually remove all the elements, and after you clear you can see whether it's empty or not. Then after that you can insert some elements to it, and again you see the whether it's empty or not. Right, so let me see what will be the output of this code. So now you can see in the first case it was false because there were elements, and then it was cleared and it became true. It was empty, and then once the element was inserted it becomes false. That means it was not empty, right? So this was about some of the features of the vector. And the next thing I want to talk here is passing the vector to a function. You can pass the vector to a function in a way similar to how you would pass a class or user defined class or class you define yourself into a function class object. For example, instead of displaying this capacity and size through this statement, I would actually create a function to display size capacity. Right, so for this I need to pass the vector. The type of the type I want to pass here is type of the object I want to pass here is going to be obviously vector, but it has to be instantiated for int type. So now inside you can place this the statement for displaying the size and capacity through this the same name, because I have used the IVEC, so I don't need to make change here. Now here I don't need all this statement, I just pass right? So comment these things out. And I could also put place this entire thing inside. So let me have this entire thing, so that instead of size and capacity I would also want to display the content. So right, this is going to be the content. So I want to comment this out as well, because this thing is going to be already displayed there. And here, let me compile this code just to see that it works. The passing, particularly the passing of the vector object into the function. There is one issue. I actually I missed to change the name of the object inside the function. So let me make this change. So it should be ivec. So I actually, when I copied the code, I actually missed to make the necessary changes. Now let me compile. Execution. Now you can see it is displaying, right? It's displaying the size, capacity, and the content. So initially content was 0. When it was empty, then 20, content 0 and 200 and all these things. So now going back to a little more discussion about passing to the function. If usually when you're passing the vector, usually typically when in programming and in real world software applications, the size of this vector can be very large, because this vector may be containing not only the integer, but it could be the object of some big some classes or types which may be holding a big data. So if you want to do like this, it will attempt to copy the data into this function. So that would be very expensive, because in this case we are not making any changes, we are only using it. So if you are passing the vector object which actually carries a big data size, it is always recommended you pass by reference. And if this function is not to make any changes to this, then you make it not modifiable, constant. Okay, so this is how you want to pass the objects, particularly the container objects, into the function, right? So these are the things you want to be careful about if you want to be better programmer or more professional programmer. So now I'm going to be talking a little bit one additional thing that may be interesting to you, I hope. So to access the element of a vector, there are two ways. Here, where was it? There was a loop. In this loop, we used this subscripting operator. The vector class also gives you offers you another way of accessing the element, right? If I want to use the same function to access the element, let me just make changes to it so that I want to only use this to access the element, to simplify the things. And maybe I may want to change the name of the function as well. So access using, I actually am trying to demonstrate the use of the access of the elements by using square bracket or the subscripting operator and at. So square bracket, right? I want to pass the index, and I just want to access like this. Right, so this is all I want to do. And if you want to display it, you also may want to display. If you don't display, then sometimes some of the compilers will flag this as a warning, not the variable defined not used. So if you want to avoid those warnings, then you can have some statement that actually uses it. And I want to access using the another function which is the function at. So this is also function you can call to get access to the element. So the purpose here is to see the difference between this indexing operator, subscripting operator, and this function at. So the difference here is, let me keep only one vector. I want to keep let's say IVEC only, remove all these things, push back, so I have 1 2 3 5 elements in this vector now. I actually will be calling this access square bracket, and access is going to be access at, right? Access using at, access using square bracket. So these are the two ways of these two function invocation will actually access the elements by using different ways. So let me compile and see the output, and I will explain it further. Okay, too few arguments, so I actually yeah, because this function receives index as well, so I also want to give index, let's say 2. So now it is accessing the data, right? But the main point I want to explain here is these two ways give access, but this subscripting operator actually accesses by without checking whether the index is valid or not. In this case, the index, the vector has 5 elements, so valid values of the index would be 0, 1 2 3 4. These are going to be the valid values, and the all the integers outside this range are going to be invalid, right? So if you it will allow you access with both valid and invalid indices, but in this case it will check whether the index is valid or not. Okay, so therefore this 8 will provide more safety, but this direct access without validation will actually allow you more, faster performance, better performance or faster execution of the code, right? I will show you this. So to see this, I need to check the amount of time that is required, that will be required to execute this line. So for that I want to use the library to measure the time, which is chrono. So chrono library will give me access to the tools that I can stamp the time at this point. I want to record the time before this line is executed. So now this will be time at this point will be actually recorded in this variable t1, and at this point I want to also record the time and I want to actually compute the time difference. So time difference is equal to we need to get the duration, double type, and microsecond t2 minus t1, right? So now instead of displaying the data, I also want to display the time. Access this data in time using this operator. Now time difference dot count. So this is how you actually access the time required to execute this statement. Now I can do the same in the access at function. But in this case I'm using at, right? So now this should display the time difference, the difference in the time required to access this element using this soft scripting operator, and time required to access this element by calling this method at. Let me see the time difference now. So there is a small error here, has not been declared. I think there is some small typo problem. So chronos, so now we have it was accessed first accessed is in 0.1 microsecond. It was a 0.2 microsecond, right? So if I run again, maybe 10, may not be convincing. This data is not convincing, definitely. So if I want to get only convincing output, then maybe I want to execute this for multiple times, right? For I equals to 0, I less than, let's say 1000, I plus plus. So now if we execute the same thing for multiple times, then maybe total amount of time would we may be able to see the difference. Right, so let me see the output with this change. So now you can see 1.9, 5.4 time difference, again 1.9, 5.3, again 129. So it is very consistent. So time required by calling the method at is much higher than the time required time required for accessing the element through the subscripting operator. Right, so you can see it's very consistent. So now again, to repeat it, method at the method at checks whether or not the index is within the bound, but the subscripting operator does not do that. And you can see the use of this two methods. Basically this operator is also one of the function, member function or method of the class. So use of these two methods as a trading off between the safety and efficiency. Thank you for watching the video. This is the end of